child, you may have noticed that when looking at a fish in a water, in a pond or aquarium, you can often see a reflection of the fish on the water surface. Let's understand why this happens. We have previously learnt about the phenomena of refraction of light. We know that when light passes from an optically denser to rarer medium, the refracted ray bends away from the normal. As the angle of incidence is increased, the corresponding angle of refraction also keeps increasing until it becomes 90 degree and grazes through the surface. This particular angle of incidence in the denser medium for which the angle of refraction is 90 degree is known as the critical angle. When the angle of incidence in the denser medium exceeds the critical angle, the refraction is not possible. So the ray is totally reflected back into the same medium. This phenomenon is known as total internal reflection. Thus, the requirement for the phenomenon of total internal reflection to take place are: the light ray should travel from an optically denser medium to an optically rarer medium. Also, the angle of incidence in the denser medium must be greater than the critical angle for the given pair of media. From Snell's law of refraction, we can show that the refractive index of the system is equal to the sine of the critical angle. Let's now study some occurrences of the phenomenon of total internal reflection in nature. Mirage. During a cool day, temperature of the atmosphere is uniform and there is not much refraction as air density is also uniform. During hot summer days, the air near the ground surface is hotter in comparison to the layer of the air above it. Hotter air is less dense and hence has smaller refractive index compared to cooler air. If the air is still, the refractive index of different layers of air progressively increases with increase in height from the surface of the ground. Hence, light from tall objects such as trees and hills have to pass from optically denser air to rarer layers as they reach the human eye. Thus, the ray of light successively bends away from the normal and undergoes total internal reflection. To a distant observer, the light appears to be coming from somewhere below the ground, as if reflected from a pool of water on the ground. This phenomenon is called mirage and is common especially in hot deserts. The brilliance of diamonds is another example. Diamonds have a very small critical angle of around 24.4 degree. Hence, light entering the diamond is likely to undergo total internal reflection. Cutting the diamond suitably ensures multiple total internal reflection events, giving rise to the brilliant sparkle. Optical fibers. Optical fibers are composed of high-quality composite glass or quartz core and cladding. The refractive index of the core is greater than that of the cladding. When light ray enters the fiber through the core and falls on the cladding, it suffers total internal reflection as the angle formed by the ray is greater than the critical angle. Light that reflects from one side and strikes the other at an angle greater than the critical angle, it undergoes repeated reflections along the length of the fiber and finally comes out at the other end. Even if the fiber is bent, light can travel easily along its length. Optical fibers are extensively used for transmission of signals over long distances. Let's summarize what we have learned so far.
Manorama Horizon. Learning made simple.